You see, sometimes people in positions of authority convince themselves that their logic is flawless. They have meetings, charts, and committees, and they all nod in agreement, assuming that numbers and procedures are proof enough. But when you step back and actually look at what's happening, the truth can be far simpler and far more dangerous than anyone admits. Take, for example, a situation where a machine is meant to work perfectly under all conditions. Engineers write reports, managers approve launches, and the public assumes everything is fine. But if you ask a simple question, just one tiny inconvenient question, you might find a flaw that no committee dared to consider. Something like, what happens to this part if it gets really cold? Now, most people might glance at the manual, check some charts, and say that's within the acceptable range, everything is fine. But real critical thinking doesn't stop at charts. It doesn't stop at assumptions. You need to test, to experiment, to see the actual behavior of the system under real conditions. You have to take it out of the report and put it in your hands, even if it's uncomfortable, even if it challenges the consensus. And then you see it. A tiny ring of rubber that hardens in the cold, something everyone assumed was fine, suddenly becomes the weak link that could destroy an entire mission. It's small, almost invisible, but its effect is catastrophic. A simple experiment, a glass of ice water, a careful observation reveals what all the reports, all the logic, and all the meetings had missed. This is the power of thinking critically. It's not about memorizing formulas, repeating procedures, or trusting authority blindly. It's about asking the questions no one else dares to ask. It's about testing assumptions, following the evidence wherever it leads, and not being afraid to point out the obvious when everyone else is too polite or too scared to notice. Critical thinking, in its purest form, strips away the pretenses and exposes reality. It's uncomfortable because it often contradicts authority and defies bureaucracy. But it's also liberating because it allows the truth to shine through, no matter how inconvenient. And in moments like these, the truth isn't just enlightening. It can save lives. In the end, logic isn't about looking smart on paper. Logic is about understanding nature, about seeing clearly, and about refusing to let assumptions or hierarchy blind you. Test everything, question everything, and never, ever let convention stand in the way of reality. That is how real knowledge works. It's amazing how often people assume that just because someone wears a title, sits in a committee, or produces a report, their conclusions must be correct. We see it everywhere, in science, in engineering, in business, even in everyday life. People trust authority blindly, thinking that the charts, the graphs, the statistics, and the meetings are proof enough. But the truth is, authority alone tells you nothing about reality. Reality doesn't care about committees, titles, or polite consensus. It obeys its own rules, and it often doesn't make exceptions for people who are important to really understand something. You can't just read what someone else says. You have to look, observe, and question. You have to be willing to say, wait a second, are we sure this is correct? Even if everyone else nods and agrees. That's the first principle of critical thinking. Don't trust authority, trust evidence. This doesn't mean disrespecting expertise. It doesn't mean ignoring knowledge. It means using authority as a starting point, not a final answer. Experts can guide you, but they can also be wrong, especially when groupthink sets in, when procedures become ritual, or when convenient assumptions go untested. Authority can give you confidence, but confidence is not the same as truth. The moment you assume something is correct simply because an expert says it is, you stop observing for yourself. You stop thinking for yourself. And that is exactly when mistakes creep in. It's like walking across a bridge because the engineer said it's safe, without ever noticing the cracks forming in the concrete. At some point, reality will remind you, sometimes gently, sometimes violently, that authority is not infallible. Real understanding comes from asking the right questions. Even small, seemingly silly questions can reveal enormous problems. Asking, what if this gets very cold? Or what happens if this part fails? Might seem trivial compared to the complex reports and calculations everyone else is producing. Yet often, These are the questions that uncover the flaws hidden beneath layers of bureaucracy and overconfidence. The bigger the organization, the more critical this questioning becomes, because group consensus tends to smooth over inconvenient details. Questioning authority also requires courage. It's uncomfortable to challenge assumptions in a room full of people who believe they are right. It's uncomfortable to be the one pointing out that a plan might fail when everyone else is celebrating its brilliance. But the discomfort is a sign that you are thinking critically. The discomfort is a sign that you are engaging with reality rather than illusions of consensus. Without it, knowledge is shallow, and mistakes go unnoticed until it's too late. Ultimately, questioning authority is not an act of rebellion, it's an act of responsibility. It's about insisting that reality, not hierarchy, determines outcomes. It's about looking at a system, a plan, or a procedure, and saying, let's see if it really works, not just on paper, but in the real world. This approach keeps errors small, saves time, and sometimes even saves lives. Because the world is indifferent, and if we don't pay attention, the consequences of unquestioned authority can be severe. So, the lesson is simple but profound. Never assume that someone else's certainty equals truth. Test it, observe it, question it. Authority can guide you, but evidence will show you the way. Trust the world, not the titles, and you will find clarity, understanding, and, most importantly, safety in the midst of complexity. Assumptions are dangerous because they give us the illusion of understanding. We often proceed as if something is true simply because it makes sense on paper, because everyone else accepts it, or because it aligns with conventional wisdom. But the world doesn't care about what makes sense to humans, or what looks neat in a report. Nature follows its own rules, and assumptions that are left untested can lead to disasters, sometimes small, sometimes catastrophic. That's why testing assumptions is not optional, it is essential. Most people think testing assumptions is complicated. They imagine complex experiments, expensive equipment, and endless calculations. But the truth is that testing can be incredibly simple, as long as you are willing to see and question. It's about taking a principle, an idea, or a plan and asking, what if this is wrong? Then you try to prove yourself wrong. If you can't, then perhaps it's safe to proceed. If you can, then you've uncovered something critical before it becomes a real problem. This method is not theoretical, it's practical, it's tangible, and it works every time. The danger of unchecked assumptions is that they often hide in plain sight. People assume materials will behave as expected, that conditions will remain normal, that procedures are foolproof. In reality, extreme temperatures, unusual stress, or small flaws can completely change outcomes. When you don't test these assumptions, you are operating on faith rather than knowledge. And faith in engineering, science, or safety is a dangerous game. Reality is indifferent, and it will not accommodate your comfort or your pride. Testing assumptions also forces humility. It reminds you that even the most brilliant minds can overlook the simplest details. It is a practice in honesty, a way of confronting your own fallibility. When you put an assumption to the test, you might discover that it is correct, or you might discover a flaw so obvious in hindsight that you wonder how anyone missed it. Either way, the process sharpens understanding and builds confidence that is grounded in reality, not convenience. Sometimes the best tests are remarkably simple. A tiny experiment, a small demonstration, or even a thought experiment can reveal the weakness in an assumption that no amount of theory or paperwork could expose. These tests often highlight the limits of knowledge that reports, charts, or authorities cannot show. They cut through bureaucracy and consensus, replacing assumptions with evidence. They turn vague certainty into tangible understanding. Testing assumptions also cultivates a mindset of curiosity. When you make it a habit to question and verify, you begin to see the world differently. Nothing is taken for granted, and every claim is an opportunity to explore. This approach is not pessimistic. It's practical and constructive. It doesn't reject knowledge. It strengthens it. It doesn't slow progress. It prevents failures that could have been catastrophic. In the end, testing assumptions is about aligning thought with reality. It is about refusing to accept things at face value and insisting that ideas meet the rigors of observation. It is a safeguard against error, a tool for understanding, and a path to true insight. Every assumption carries risk, but testing that assumption transforms risk into knowledge. It is the difference between believing something is safe and knowing it is safe. In a world where consequences matter, where small flaws can have enormous impact, testing assumptions is not just a practice, it is a responsibility. It's funny how humans often overlook the smallest things. We tend to focus on the big picture, the grand theories, the impressive calculations, and the elegant designs. We admire complexity, celebrate innovation, and chase breakthroughs. Yet time and again, it's the tiniest, simplest detail that determines success or failure. A minor part, a single sentence in a manual, a subtle environmental factor. These are the things that carry enormous consequences, and they are often the things that no one notices until it's too late. Small details matter because the world is unforgiving. Systems, whether mechanical, natural, or human-made, are composed of countless interacting parts. Each part may seem insignificant on its own, but when combined, even the tiniest flaw can ripple through the system and cause failure. It's like a chain. One weak link, no matter how small, can break the entire chain. And yet, people often assume that because a part is minor, because it has always worked before, or because it seems trivial, it doesn't need careful attention. That assumption is precisely what leads to disaster. The importance of small details becomes clear when you actually look at how things behave in reality. Engineers can design with precision, scientists can calculate with care, and managers can plan meticulously. But if one small assumption about a minor component is wrong, the plan can fail spectacularly. It may not be obvious at first glance. The error can be hidden under layers of calculations, IED in reports, or masked by appearances. That's why it's crucial to focus on the details that seem insignificant. They are often the most significant. Observing these details requires patience and curiosity. It's not enough to glance over instructions, read a chart, or trust a description. You need to examine, measure, and understand. You need to see how each component behaves under different conditions, how it interacts with others, and how it responds to stress. Sometimes the smallest thing, a rubber ring that hardens in cold temperatures, a minor crack in a surface, a tiny misalignment, can determine the difference between success and failure. These details are the silent arbiters of reality. Small details also teach humility. They remind us that no matter how intelligent, experienced, or well-informed we are, we can overlook something critical. It's a humbling lesson that encourages constant vigilance, experimentation, and verification. The world doesn't forgive arrogance or assumption, and ignoring minor elements is a form of intellectual arrogance. When you pay attention to the small things, you not only prevent mistakes, but you also deepen your understanding of how systems truly operate. In practice, attending to details often means asking simple questions. What if this behaves differently than expected? What happens if conditions change slightly? How does this tiny component affect the larger system? These questions may seem mundane, even tedious, compared to the big ideas everyone celebrates, but it's in the answers that insight emerges. The smallest details often hold the key to safety, efficiency, and reliability. Ultimately, appreciating small details is out-respecting reality. It's a commitment to seeing things as they truly are, rather than as we hope or assume they are. It's about understanding that complexity doesn't guarantee safety and that elegance doesn't guarantee correctness. Even the tiniest element can determine the outcome, and ignoring it is a risk no intelligent thinker should take. Small details are not trivial. They are the threads that hold the tapestry together, the subtle forces that shape outcomes, and the hidden determinants of success. In the end, attention to the small things separates those who understand reality from those who are merely impressed by appearances. Consensus is a curious thing. People often assume that if everyone agrees on something, it must be true. Meetings are held, reports are signed, committees vote, and charts are approved, and suddenly the world believes that agreement equals correctness. But nature does not care about consensus. Reality does not bend to the will of committees or the comfort of popular opinion. 100 people nodding in agreement does not make a flawed assumption correct. Evidence, not consensus, is what matters, and recognizing this is the cornerstone of clear thinking. Too often humans fall into the trap of social proof. If everyone says it is safe, it must be safe. If everyone says the calculations are correct, they must be correct. But group agreement is a social construct, not a physical law. Consensus is fragile because it is shaped by communication, hierarchy, convenience, and sometimes fear. People may nod along to avoid conflict or embarrassment, or simply because they trust authority. None of these factors guarantee truth. Reality is indifferent, and it will follow its own rules regardless of what committees, experts, or society at large believes. Evidence, on the other hand, is stubborn. It doesn't care about titles, votes, or consensus. Evidence comes from observation, measurement, and experimentation. It is the check on human assumption, the reality test for our ideas. When we prioritize evidence over consensus, we are forcing our ideas to meet the standard of the world itself, not the standard of opinion. This is a rigorous, demanding process because evidence is often inconvenient, contradictory, or difficult to interpret. It requires patience, curiosity, and humility, but it is the only way to understand how the world truly works. Sometimes the difference between evidence and consensus is stark. A group might assume that a system is flawless, that a plan is safe, or that a procedure works under all conditions. Everyone agrees, everyone trusts the reports, and yet the evidence might tell a completely different story. A simple experiment, a careful measurement, or even a small observation can reveal a flaw that no meeting report or chart had predicted. Consensus can lull people into a false sense of security, but evidence forces them to face reality. Prioritizing evidence over consensus is not about disrespecting expertise or ignoring experience. It is about putting ideas to the test. Experts can provide guidance, but even the most brilliant minds can be wrong when assumptions go untested or when group dynamics override careful thinking. Evidence is impartial and merciless. It will confirm or refute any claim, regardless of who made it or how many people believe it. This impartiality is what makes evidence so powerful and consensus so potentially dangerous. Valuing evidence over consensus also fosters a mindset of independence and curiosity. It encourages asking uncomfortable questions, testing assumptions, and following where the data leads. It teaches us to be skeptical of easy answers and to dig deeper, even when the answers challenge authority, tradition, or popular belief. In a world full of noise, consensus can create the illusion of certainty, while evidence reveals the truth. The two are rarely identical, and wisdom lies in recognizing that evidence, not agreement, is the ultimate guide. In the end, choosing evidence over consensus is about aligning your understanding with reality, not with opinion. It's about insisting that your ideas stand up to observation and experiment, even if it means going against the majority. Consensus may make us feel comfortable, but evidence makes us correct. And in a world where errors can have enormous consequences, correctness matters far more than agreement. True thinking begins not with nodding heads, but with stubborn, curious, unflinching attention to the facts themselves. There's a certain beauty in simplicity. You can have all the charts, all the calculations, and all the theories in the world. But until you put an idea to the test, you don't really know if it works. Practical experiments are the ultimate test of understanding. They are the bridge between thought and reality, between abstract reasoning and the world as it actually behaves. Thinking without testing is like building a house in the clouds. It might be beautiful on paper, but it will collapse the moment reality intervenes. Experiments don't have to be complicated. Some of the most revealing tests are surprisingly simple. You don't need massive equipment or elaborate procedures to uncover the truth. Often it's the small, hands-on tests that expose the flaws in assumptions, reveal hidden problems, or show the limits of a system. A quick demonstration, A simple observation or a tiny modification can produce results that no report or committee discussion ever could. The key is to actually see what happens rather than assume what should happen. The beauty of practical experiments lies in their immediacy. They provide direct feedback, showing us where our understanding is accurate and where it falls short. When you test a theory or assumption, you remove the layers of abstraction and confront reality head-on. If the result matches your expectations, you gain confidence grounded in evidence. If it doesn't, you have an opportunity to learn, to adjust, and to improve before the consequences of error become severe. This direct, unfiltered interaction with reality is far more valuable than any consensus or calculation on paper. Practical experiments also cultivate curiosity and a playful approach to learning. When you test something yourself, you begin to notice details you would have missed otherwise. You start asking new questions, probing deeper, and exploring possibilities beyond the original assumption. It's a form of active thinking, engaging with the world rather than passively accepting information. And often, the discoveries you make in these small experiments are far more insightful than anything theoretical. They teach lessons that are tangible, memorable, and profound. Another important aspect of practical experiments is that they reveal the unexpected. The world does not always follow the neat patterns we predict. Materials behave differently under stress. Temperatures alter performance, and tiny interactions can have outsized effects. By testing in the real world, you encounter these surprises before they become disasters. The beauty of experimentation is that it confronts you with reality, forcing you to reconcile theory with fact and giving you the chance to adjust before relying on assumptions in high-stakes situations. Practical experiments are also a lesson in humility. They remind us that no matter how smart we are, no matter how much we calculate or plan, reality can always surprise us. The world is not obligated to follow our logic or our reports. It operates according to its own rules, indifferent to our expectations. When we test ideas hands-on, we learn to respect that reality, to trust evidence over assumptions, and to value observation above all. In the end, practical experiments are the heart of understanding. They transform abstract ideas into lived experience, turning assumptions into knowledge and theories into verified truth. They are not just tools of science or engineering, they are tools of clear thinking, critical reasoning, and effective problem solving. Testing, observing, and experimenting are how we truly engage with the world. Without them, knowledge remains fragile and uncertain. With them, even the most complex systems can be understood, and even the most daunting problems become approachable. In a world where the smallest error can have enormous consequences, practical experiments are not optional, they are essential. They are the lens rough which reality becomes clear, reliable, and undeniable. Logic is a beautiful thing when used correctly, but too often people treat it as a performance, a way to look smart, to impress others with complicated arguments, charts, and calculations. They parade it like a badge of intelligence, as if making things sound complicated automatically proves they are correct. True logic, however, has nothing to do with appearances or prestige. Logic is a tool, a precise instrument for understanding the world, for uncovering truth, and for solving problems. When treated as a show, it loses its power and can even become dangerous. The purpose of logic is to help you think clearly, to break down complex problems into manageable parts, and to connect cause and effect in a way that corresponds to reality. It is a means, not an end. It's not about making arguments sound clever or convincing others of your superiority. Real logic is practical, applied, and rooted in evidence. Its measure is not how impressive it seems on paper, but how well it helps you understand reality, predict outcomes, and avoid mistakes. When people use logic as a show, they tend to skip the hard part, verification. They assume that if the argument is neat and the equations elegant, it must be correct. They substitute appearance for understanding, elegance for evidence. But the world does not care about elegance or appearances. A beautifully constructed argument can still be wrong if the assumptions are flawed, if the data is incomplete, or if the conditions change. Logic is only useful when it interacts with reality, not when it sits in isolation as a performance. True logic demands humility. It requires acknowledging what you don't know, questioning your assumptions, and testing your conclusions against observation. It's a way to wrestle with reality honestly, rather than to win arguments. When used as a tool, logic allows you to simplify complex problems, identify the critical variables, and focus your attention on what really matters. It helps you avoid errors that arise from intuition, tradition, or consensus, guiding you to solutions that are grounded in fact rather than in the applause of others. Logic as a tool is also iterative. You propose a solution, test it, observe the results, and adjust your reasoning accordingly. Each step strengthens your understanding and refines your conclusions. It is dynamic, flexible, and always connected to evidence. By contrast, logic as a show is static. It stops at the argument. It celebrates the construction, not the outcome. It values style over substance, certainty over truth, and cleverness over understanding. The difference is subtle, but the consequences can be enormous. When logic is applied properly, it empowers curiosity and experimentation. It allows you to break problems down to their fundamentals, to ask simple questions that reveal hidden flaws, and to find clarity where others see only confusion. It turns thinking into an active process, a way to engage with the world rather than a way to impress observers. Logic is a flashlight in a dark room, revealing what is real, what is important, and what can be acted upon. Ultimately, logic must serve reality, not ego. It must help you see clearly, solve problems, and understand the world as it actually is. Treating it as a show corrupts its purpose, making it a tool for illusion rather than insight. But when you use logic as a practical instrument, tested, verified, and grounded in evidence, it becomes one of the most powerful ways to navigate complexity, avoid mistakes, and uncover truth. Logic is not for performance, it is for understanding, and it works best when it is humble, precise, and relentlessly focused on reality rather than appearances.